Now we'll be looking at calculating loss values. Without a loss value, there's no way to know how well our neural network is doing. So we do this by estimating how well our loss value is, our network is, by calculating the loss. And there are two scenarios: either we're predicting a categorical value or a continuous value. So categorical is discrete. Let's say we have five classes: cat, dog, and some others in our as our prediction. So those are discrete bucket of value. But in continuous variables, let's say we're predicting a number like 2.3 house or price of a house. So those are infinite values. It could range, the values could be infinite. If it's 2.3, it could be 2.3.1, 2.3.2, and on and on. So based on that, there are different loss functions that are suitable depending on the type, on the scenario. So if it is a continuous variable, generally you use loss function like mean square error, and this is the equation, mathematical equation of a mean square error. All you do is that you take your true values, your prediction value, and you subtract them, you square it, and you sum it over all the instances, and you normalize by the total number of instances. That's essentially what this does. So these are mathematical formulation of what a predicted is and what the actual is. So that's that. So now what we're doing is that the y hat is what your network is predicting. So if you represent your network as a function, here we're using this mathematical notation as a function, and it's parameterized with theta, where theta is the set of weights that your neural network is learning. If you supply an instance, an input into your network, it gives us a prediction, and that prediction is what we use to calculate the loss values. Alright, so based on our previous lecture, we got a loss value of 1.235 for our network. Then we want to measure the loss, so we just key in the values. So the prediction is 1.235 and the actual value should be 0. By the time we do that, our loss will give us 1.52. So this is the loss. So this shows that we have a very high loss because we want our loss to be as close as possible to 0. Alright, that's understandable. But if we are predicting like a categorical variable, we use a different loss function. Typically we use the cross-entropy loss. If it is just two discrete values, let's say 1 or 0, just two, if it is binary, we use what we call the binary cross entropy, and this is the formula of the binary cross entropy. M is always the number of instances in our training or in the batch. Yi is always the actual value, and here the Pi is actually the predicted value, which we actually now take the log of that. So you could see that this is, we are summing this one, and so we subtract each of them from 1 on the other side, and we add it to the product here. But if it is a categorical values, this is the formula for that. So this is more than 2. So those are standard formulas for optimizing our neural network. So let's see what happens in case where we have categorical values. So here we have 5 classes. So, and our network can say, let's say our network gives us a prediction like this. So let's say at inference we give a particular instance, and the network gives us these predictions. So the network gives us a flow of all of this. So what we do is that we calculate the cross entropy loss, and we get this, and this is what we optimize. So now each row has to sum up to 1. So the prediction has to sum up to 1. So the probability that our network is must sum up to 1. So the final loss is the mean, like I've mentioned earlier. So that's essentially that for calculating loss in neural network. Thank you and see you in the next one.